Hello friends. In this section, we will discuss about technical indicators, what they are, why do we use them, and how can we code them using Python. And I'm sure that most of you already know about technical indicators and you use them in your technical analysis as part of your strategies. And if you are quite familiar with this, then you can feel free to skip these lecture videos. But in this section, when we discuss about the Python implementation of technical indicators, I would encourage you to just take a look because that's something that is going to be important as we go forward in the course. Okay. So technical indicators have nothing but some kind of mathematical calculations and implementations using stock data like historical price, volume, open interest, etc. Right? So they are used to perform analysis like trend analysis, predict direction of asset prices and things like that. They are widely used, so it's recommended that even if you are not going to use them, it's no harm to just learn how a lot of traders are using this for their strategies. Okay. So technical indicators are fundamental part of something called technical analysis. And this technical analysis involves analyzing trends of stocks, just studying chart patterns and things like that. Okay. Most technical indicators are lagging indicators. And this is a very important point. Technical indicators are mostly used to confirm trends. Okay. So they are not something that are typically used to predict which direction the asset prices are going to take. Although there are some technical indicators which are leading indicators, right? Mostly volume-based that are used for that. But on a whole, in general, technical indicators are lagging indicators and they are used to confirm something that you have witnessed. Typically, they are also used in conjunction with other technical indicators, right? You would not just use one technical indicator and be done with it, right? Typically, you will use a couple of technical indicators to ensure that the signal generated by the first TI is reinforced by the signal generated by the second TI. Okay, so that's something that most traders do. So something to keep in mind. Okay, the next point is also an important point, and which is technical analysis is very different from fundamental analysis. Actually, there is this huge debate about which kind of analysis is more superior, fundamental analysis or technical analysis. And what goes in favor of technical indicator proponents is something called efficient market hypothesis, which you must have studied in your finance, right? So what efficient market hypothesis states is that markets are efficient, fully efficient, and if there is any new news that is published or that is released to the market, right, it is immediately kind of incorporated in the asset prices, right? So technical analysts would kind of laugh at fundamental analysts like, why are you spending time analyzing all those financial ratios and all the balance sheet and everything, right? Because as soon as this was published, it was incorporated into the to the asset price. So all we need to concern ourselves is to look at the trend of the asset price and kind of get into the trade and things like that. There is no point doing fundamental analysis. Again, I am not saying that one is more superior over other. I also use fundamental analysis and I also use technical analysis. So I do not want to walk into this debate between fundamental analysis and technical analysis, but it's just something that I want to kind of put it out there, that there are these two schools of thoughts, and it's no harm to use both fundamental analysis and technical analysis. Okay. Then there are some popular technical indicators, right? For example, MACD, Bollinger Band, RSI, and we'll discuss some of them, right? And the idea is that you should be able to kind of analyze what is the foundation of a technical indicator, and you should be able to code it in Python. Okay. So that's all I wanted to cover in this lecture video, just to give you a gentle introduction of what technical indicators are. In the next lecture video, we'll start discussing technical indicators and coding them in Python. Thanks a lot. Hello friends. Before we start implementing these technical indicators in Python, I want to spend some time showing where you can access these technical indicators on your MetaTrader terminal, and also where we can get more information about these specific indicators. So for example, I have this AUD NZD 30-minute chart open in front of me. And you can see that I already have this technical indicator superimposed on this chart. So to remove a technical indicator from a chart, you can right-click on that technical indicator anywhere on that particular panel and then click on Delete Indicators window. And let's say I want to insert a technical indicator on this chart. So you'll click on Insert, then go to Indicators, and then choose from the bunch of technical indicators which is already provided to you. So some of the popular technical indicators that we will cover in this particular section are like MACD, etc., or moving averages and things like that. So you might have to search for these technical indicators from these technical indicator families. So TIs can be categorized as trend technical indicators, oscillators, volume-based technical indicators, etc. Alright, so if you know which family that technical indicator belongs to, you can just go to that particular family and choose from the drop-down which one you want to insert on the chart. Or if you're not sure about the family, just go to Custom. And here you have the list of all the technical indicators that are available for you to insert on your chart. Alright, so in this case, I know that MACD is an oscillator, so let me insert MACD again. And once you insert a technical indicator, it will ask you for some parameters, and we'll discuss these parameters when I'm actually explaining those technical indicators. So right now, don't worry about them. I'm just going to click OK with the default parameters, and then I will have that particular technical indicator panel inserted on that particular chart. Now, problem is that you won't find all the technical indicators that you want in your indicators panel. So if that's the case, you may want to go to this code base tab within the toolbox panel of your terminal. So if I go to code base, you will see a number of things here. Alright, and this code base simply is an aggregation of all the codes and scripts that MT5 users can use to automate their strategies. If I right click anywhere here, right now I have expert advisors, indicators and scripts within my code base. Actually, I don't want expert advisors and I don't want scripts. I only want indicators. So these are all the indicators that other people have coded for you to use, and you can very simply download them and include them as part of your indicators database. I have a lot of technical indicators here, so let's take one for example. Let's take parabolic SAR. So by default, I don't have this particular technical indicators on my MT5. So what I can do is right click here and click on download. As soon as I download this particular script would be downloaded and saved in the folder where your MT5 is actually configured within your system. And once I download it, I will be able to see that particular indicator in my navigator panel. So right now, if you look into my navigator, you see that I have trend, oscillator, volume, Bill William, etc. When I downloaded MT5, I got all these technical indicators by default. But then I downloaded a few, and these are the technical indicators that I have downloaded. And you can see that I already have parabolic SAR and Renko. These are two indicators that I actually downloaded. And once you download it, you'll be able to find it within your indicators option. Alright, so if I go to custom and if I go to P, you see that I've got parabolic SAR here. Alright, so this is how we download it. Now, you may not want to download something right away. You may want to learn about it before downloading it. So to do that, you can right click and click on view. And as soon as you do that, it will open the relevant documentation page on the MQL5 website. If you recall, in the initial section of this course, I explained to you the MetaTrader ecosystem. You have forum, you have market, you have signals that you can buy, etc. And there's a tab called Education. It has articles, code bases, documentations, whatnot. So you can search for a given technical indicator on this website as well. Just click on the search button and then just click on whatever technical indicator you are interested in, MACD, whatever. And it will give you a link to this education page. So here, whoever has coded this particular technical indicator would explain what they are trying to do. And more often than not, they will always have the calculation as well. What actual calculation they are performing, which could be very helpful if you're trying to replicate this particular technical indicator in Python. And one very important thing that I should clarify at this point is that any code that you will see in this particular location is going to be in MQL5 language. It's not going to be in Python. That is very important. So we will have to look at these calculation logic, and then we'll have to try to replicate this in Python, because unfortunately, as of now, everything pertaining to this ecosystem, for example, the signals, their virtual machine, their indicators, their expert advisors, everything is coded in the MQL5 language, which is very close to C++. So for example, this is the actual code. Every MQL5 script has .mq5 suffix. So what you can do is you can click on this and it will download it into your local machine. So let me actually show you how it looks when you download it. Alright, so I downloaded this into my local machine, and this is the MQL5 source file. You can see that this is the MQL5 source file. So essentially this is a script. So you can open this in Notepad++, but if you recall, when you installed MetaTrader on your machine, it installed two important software. One was the MT5 Terminal, and second was an MT5 editor. So if I double click on this, by default, it will open this particular script in the software called MetaEditor. So MetaEditor and MT5 Terminal are the two important softwares that gets downloaded onto your system once you download and install MT5. And this is how the MetaEditor looks. Again, MetaEditor is simply an IDE, very similar to Spider or other IDEs that we are using, but this is used solely to run and compile MQL5 scripts. Alright, so if I want to run this particular code, I will have to do it using MetaEditor. We are not going to cover MQL5 code and how to run them, etc. in this course. All I'm telling you to do is that if you want to access this particular code, you can open it in MetaEditor, or you can even open it in Notepad++. That should be fine. It's just a script. Go through it and see if you understand what they have done, because eventually they will have to replicate this code or script in Python. We can't use MQL5 script in a Python program, unfortunately. Therefore, the idea is that we will have to replicate it. And if you have some knowledge of C++, it's not that difficult to figure out what they are doing. However, I understand that not everyone can read C++ codes and replicate them into Python. So what I'm going to suggest is that you don't worry about the MQL5 ecosystem when you want to code Python technical indicators. So let me close this. Instead, I'm going to recommend that we use TradingView to get the logic for our technical indicators. So TradingView has now pretty much become the golden standard of the technical indicators that pretty much any platform use. And they have provided an excellent documentation that provides very good information about how you can code a given technical indicator in pretty much any language that you want. So for example, when you open tradingview.com, just search for any technical indicator. So let me search for MACD. And within script, you can see that I've got the option of moving average, convergence, divergence. And so let me click on this. And as soon as you click on it, you will see a documentation which has everything you need to know about this particular technical indicator. You'll have to click on read more to get the actual calculation. And here, if you look into this documentation, it tells you about the calculation, the history, everything. What we are concerned about is this calculation, which makes it very easy for us to implement this in Python. Alright, so the objective of this lecture video was to give you an understanding of how you can intersperse technical indicators on your MT5 terminal, how they are coded in MT5. Unfortunately, they are coded using MQL5. So unfortunately, we can't use them for our Python scripts. And then I explained to you what are different ways by which you can understand how a given technical indicator is coded in MQL5 so that we can replicate that into Python. And I qualified that I am going to use TradingView as the resource to get the calculation logic, and that is what we are going to implement on Python. I have already tested them. They are pretty much identical. Alright, so from the next lecture video, we'll start covering individual technical indicators that we are going to use in this course, and we'll try to implement it using Python. Thanks a lot. Hello friends. So we start our technical indicator journey by learning about one of the most widely used technical indicators out there called moving average. And let me not call moving average as a specific technical indicator. They are a family of technical indicators which are not used on their own a lot, but they are a key constituent of a number of other technical indicators which are then widely used by traders. However, if you don't understand what moving averages are doing, you won't really be able to make out what the actual technical indicator is doing. And therefore, I'm spending some time explaining what moving averages are. And in this lecture video, we'll discuss both the simple moving average and the exponential moving average, which is the more widely used version on the various charting platforms. So to explain moving average, let me use the example of this USD CAD hourly chart. And first of all, let me make this a line chart and not a candlestick chart. So let me click here. All right. So as you can see, this chart is noisy. I mean, there is no smooth trend. The exchange rate goes up, stays flat, then comes down. There's a lot of up and down happening here. And we call this volatility noise. What moving average tries to do is that it tries to cut off some of this noise and give you a smoother trend. So let me go to the insert option, indicators, trend, and then moving average. Now within moving average, you can see that there is this thing called method. So let us go with the simple moving average as of now. The period, let us go with 9 period. And we'll be applying this moving average to the close price. You can choose other type of price like open, high, low, whatever. But right now, let us use the close price. And let us see how this looks. So you see, this is a much smoother version of the same price progression. All that this moving average did is that it cut out this noise. And to get a better mathematical understanding of how this smoothing is achieved, all that it does is that for each point, it takes the average of the previous n value. So for example, in this case, I'm taking 9 period moving average. So every single point on this SMA line curve would consist of the average of the previous 9 points. So for example, this point here, which corresponds to 29 January 2024, 8 a.m. Eastern European time, would be calculated by taking the close price at the same time, previous time, it goes back 9 periods. All right. So we'll take all these close prices, take the average, and this would give me the SMA at this particular timestamp. Likewise, for the previous point, you again have to go back 9 periods. And likewise, we'll do that for every single point to calculate this simple moving average. All right. So this is not that difficult to understand. Now let me change this to exponential moving average. So I can edit this indicator. You have to right click on exactly this line curve and then go to properties of moving average. Instead of simple, let us go with exponential. And now if I do OK, you see that the line changed, but it didn't change by that much. And that is because the period that we are using is only 9. If you have a larger period that you want to consider to calculate moving average like 100 or 200, you will see that the SMA and the EMA lines could significantly differ. So essentially what happens in EMA or exponential moving average is that we assign more weightage to more recent prices. And there are different mathematical ways to arrive at EMA. We will go with the one that is explained in TradingView because that's the mathematical formulation that pretty much all the platforms use. But I want to give you an intuition that in simple moving average, every single point that you use to calculate a simple moving average gets the same weightage. Whereas in exponential moving average, the more recent price gets a higher weightage. So with this intuition, let me take you to the TradingView. All right. So this is the TradingView homepage. Let me search for moving average under the scripts option. All right. So I've got this moving averages page. Let us go to read more. All right. And this is the article that tells you everything you have to know about moving averages. I've already given you the basics. So if you want, you can read it. But in essence, what I've explained to you is the same thing that this article explains. There are various types of moving averages, simple moving average. We have already discussed that. The calculation is fairly straightforward. If you have 3-period SMA, you take the 3 periods that you want to calculate the moving average for, take the simple average, and that is your simple moving average. Now let us look for exponential moving average, right? So exponential moving average assigns higher weightage to a recent data point by using something called a multiplier. Again, this is the method that TradingView has used. Others may have different ways to assign different weightage to different elements in a data series. But here, what they are doing is that they are using a multiplier. So how is the calculation? There are 3 steps. You first calculate the SMA, which is very straightforward. Then you calculate the multiplier. The multiplier as defined by TradingView is 2 divided by n plus 1, where n is the number of periods over which we calculate the moving average. So in the example that I just showed you, I was using n as 9. So based on whatever n or whatever moving average period that you're using, you can change this number. Alright, so calculating multiplier and calculating SMA is fairly straightforward. Then this EMA is a bit tricky because it's a 2-step process. The first step of calculating the EMA is finding the first EMA value. And the first EMA value is the SMA of the previous period. So this is very important for you to understand. The first EMA value is the previous period's SMA. And once you calculate the previous period EMA, then you can calculate all the other EMAs. And what's the formula? Close price minus previous EMA times multiplier plus previous period EMA. So as you can see, once you have one EMA, all the EMAs can be calculated. And this first EMA is calculated by using the simple moving average. Alright, so this is how we are going to implement EMA as well, which we'll do in the next lecture video. But if you want, you can read through this documentation. There are other exponential moving averages as well, like double exponential moving average, triple exponential moving average. All that we are doing is changing the weightage assigned to different points that we are using to calculate the moving averages, but the intuition remains the same. And in this article, they have also explained a few basic strategies which you can implement using only moving averages, although I do not recommend implementing them because these typically don't work. But if you want, you can play with these. Alright, so now that you have a fairly good intuition about moving averages, let us implement them in Python. So I'll see you in the next lecture video. Thanks. Hello friends. So let us implement different versions of moving averages, which we discussed in the previous lecture video. And the starting code to implement moving average is going to be the getting historical data function that we put together under the historical data section of this course. So I'll be using the get historical data numeric index to extract the open, high, low, and close prices for a given currency symbol. So first of all, let me initialize my trading session and run these functions. Alright, and in this code, I am using get historical data to get historical data. Actually, I didn't want that. So let me actually delete all this. I don't want to use the get historical data function. I want to use the time zone agnostic function that we discussed, get historical data numeric index. So let me run this particular function to get historical data numeric index. I'm fine with the USD CAD symbol. 30 minutes is fine, although we discussed hourly data in the last lecture video. So let me be consistent and let me use 1 hour time frame and let me quickly run this line of code. Alright, so we have got the historical data, open, high, low, close, and a number of other columns. Although I'm only going to use the close price in this case because that is the series on which I want to apply moving average. So let me create some space. Let me create a function called SMA, and the argument for SMA are going to be the series that I'm passing. So in this case, I'll be passing the close price series, and then we also have to make n as an argument. So let me use n is equal to 9 as the default value for the number of periods over which you want to calculate the simple moving average. You can change this if you want. So SMA is going to be fairly straightforward. We are going to perform a function called rolling function. So this rolling is a pandas function because we are passing a pandas series Essentially what we are going to do is that we are going to pass a column from this data frame. So every column in a data frame is a pandas series. So rolling is a pandas function and it allows you to perform a number of rolling operations on the series that you are working with. So in this case, all that I want to do is calculate the mean and I want to perform this rolling operation over these n elements. So to give you a better understanding, let me first store a value in this series variable. So series is equal to histData.close. I simply want to store the close column. So there you go. You can see SER is a pandas series and it has 200 values. And these are all the values. Okay, so if I don't want to calculate the mean, if I want to calculate the cumulative sum, I can do that. All that this will do is that it will perform a rolling sum. So if I run this, let me run this line of code as well and save the value of 9 to n. So now if I run this, it's difficult to see here. Let me create a new variable called sum or whatever. Sum is a Python reserved variable. So let me call it sum1. Just want to show you what rolling does. It's very important for you to understand the rolling function. Right? So you'll see that the first 8 values are going to be nan because we want this rolling operation to be performed on n values. So pandas need at least n values. So because n is equal to 9, till this point, 5 p.m. 17 Jan 2024, pandas doesn't have the least number of values required to calculate the rolling sum. So this is the first value, 1, 2, 3, 4, 5, 6, 7, 8, 9, when pandas has got 9 values. So if I open series, if you take the sum of the first 9 values, 1, 2, 3, 4, 5, 6, 7, 8, 9, you will get 12.1699. Now what is this 12.17? You again take the sum of 9 values starting from the next value. So 1, 2, 3, 4, 5, 6, 7, 8, 9. The sum of these values would be 12.17 and likewise. So this is essentially a rolling operation. We perform an operation on a rolling basis and the parameter for rolling is assigned. Alright, so in this case, we are not going to use sum but mean because we want to calculate the average. All that we'll have to do is return this. As simple as that. SMA is fairly straightforward. So if I run this function and then run SMA on histData.close, I will get the SMAs. Now the tricky part, which is the EMA. So just like SMA, the arguments are going to remain the same. The series that we are going to pass and the period over which we want to calculate this moving average. So nothing changes here. Now let us go back to the documentation to refresh our understanding of the mathematical implementation of EMA in TradingView. Alright, so the first thing is to calculate the SMA. It's fine, we can do that. Then it's the multiplier. So let us first get the multiplier. So let us create a variable called multiplier. And that is equal to 2 divided by n plus 1. So 2 divided by n, we already have the n as an argument, plus 1. Then we need to calculate the SMA. Why? Because the first value of EMA is going to be the SMA. We all remember that. So let us borrow this function and let us implement simple moving average using the function that we just created. Now the way we are going to calculate the EMA is that we'll first create a series of all nan values. So let me quickly run these 2 lines of code. Alright, so you see this SMA here. It is a pandas series having 200 values. So likewise, let me create an array with 200 nan values. And the idea is that we will do something and update these nan values with the actual EMA values. Alright, and there are a number of ways by which you can create a nan array or a nan series. In this case, let me create a numpy array because it will make things a bit easier. So numpy.full helps us create a numpy array. So all that we'll have to provide is the length. So the length is going to be the same length as the series that we have. In this case, it's 200. And then you have to mention what you want to fill your numpy array with. So I want to fill it with nan values. Okay, so why am I getting the error? Okay, I don't have numpy. So import numpy as np. Alright, so if I run this line of code, and if I open EMA, you see that I've got a NumPy array with all NaN values. Now we go back to the TradingView documentation. This is where the fun starts. The first EMA is the SMA of the previous day, right? So how do we calculate this? So first of all, think about it. Where is my SMA? Okay, so this is my SMA. So just like SMA, you will also have EMA, and the first value of EMA will start at the same timestamp at which the first value of SMA was calculated. That means the nth value. Alright, so the first EMA value is going to be this first SMA value. And how do we get that? So this is going to be a bit tricky. Again, there are a number of ways to skin this cat. I'm just following one way. You can do it in whatever way you want. So in this EMA array, I want to have this 1, 2, 3, 4, 5, 6, 7, 8, 9th value, or the value corresponding to index 8 as having the same value as what we have in this SMA series. Essentially what I want to do is that I want to have this 1.35221 here. Okay, so it's a bit tricky. So I want index 8. Okay, so EMA, length of the series SMA, which is 200, minus length of SMA dot drop NA. So if I remove all the NaN values, what's the length? So this would be 192. If you recall, there are 8 NaN values, and this is 200. So 200 minus 192 is 8. So EMA 8 is the 9th value. Again, it's a bit twisted way of doing the same thing. If you want, you could simply do n minus 1 here. But there are certain corner cases in which this might not work. Therefore, I am using this rather twisted way of initiating the first EMA value. So getting the first SMA value is fairly straightforward. You take the SMA, you drop all the NaN values, and then take the first value of whatever is remaining. So if I run this line of code, I will get 1.3522111, which is this value, and I'm going to assign it to the first EMA value. So if I run this, and now if I open EMA, I've got what I wanted. Alright, so I've got the first value. Now it is very straightforward. All that I need to do is run a loop, calculate this EMA for each subsequent value using the previous EMA and the multiplier. And this is the formula. Close minus previous day EMA times the multiplier plus previous day or previous period EMA. So let's do that. And we'll also have to be mindful of all these NaN values. We want to do all these calculations from this point onwards. For I in range length of the series, so we'll iterate from the first point, but we'll have to ignore the first few NaN values. If not numpy dot is NaN. So numpy dot is NaN is a function that helps us figure out whether a value is NaN or not. So what I'm doing is that I am checking whether the previous value is a valid value or not. So when would this be valid? Only when I is equal to 9. So we have a value for index 8. We want to calculate the value from index 9. Alright, so if that is true, then we will implement this expression. So let me actually copy paste it, otherwise I'll forget. Okay, so EMA I is equal to, when it says close price, we are using series as the proxy, right? So series is the close price. Okay, so series dot ilock I minus previous period's EMA. So EMA dot ilock I minus 1. The whole thing wrapped in a bracket times our multiplier. Let me wrap the whole thing in bracket again. Plus EMA dot ilock I minus 1. Okay, so let me run these few lines of code and let us see what we get. Sorry, this is an array. I don't need to use ilock. If it was a panda series, then we would use it. So let me remove this. Okay, so now if I run this, we have got our EMA. Alright, so we have got the EMA. So let me return the EMA as the return value from this function. And let us now test this on historical data. Let me rerun the historical data to make sure that we have the updated values. And let me store the EMA as a column within the same historical data. Alright, so historical data EMA is equal to EMA hist data dot close. Sorry, this will have to be capital. So now if I run this, sorry about that, I'll have to run this function. Alright, so if I open my historical data, you see that we have got an EMA and the value here is 1.3445. Let us see if we are getting the same value or not. The USD CAD hourly data, this was the EMA. If let us double check it, this is exponential period 9. Yeah, everything is the same. So if you look at this value, it is 1.344085. And look at the timestamp, 29th Jan 2024, 4 p.m. And if we look at the value here, 29th Jan 4 p.m., we have got 1.34409. So within the historical data, you'll also see this 5 p.m. candle, but this is an unfinished candle. The markets are live, and the last complete candle that we have got is still 4 p.m. Alright, so that's the value that I would compare against our calculation. So you can see that we are fairly close, 1.344085 and 1.34409. Maybe they have rounded it up. Let's look at the previous number, 1.34391, 1.343907. Again, it's surrounding 1.34391. Alright, so I have double checked it. TradingView's implementation is usually the same that pretty much every charting platform uses. Test with this code and let me know if you find something off. Alright, it's very important that you have a thorough understanding of how moving averages are calculated. So make sure that you have a firm grasp of what we discussed in this lecture video. Thanks a lot. See you in the next lecture video. Hello friends. We'll now talk about arguably the most popular technical indicator called MACD, or Moving Average Convergence Divergence. MACD is a trend-following momentum-based indicator which is calculated by taking some moving averages of a stock or an asset. What happens in MACD is that you calculate two moving averages, right? One, a slower moving average, and one, a faster moving average. When I say a slower moving average, what do I mean? I mean that the parameter that we used for calculating the moving average is longer, right? For example, 50 days or 100 days, right? So that would be a slower moving average. What would be a faster moving average? Wherein the averaging parameter, the window over which you are performing the averaging is less, 8 or 9 or something like that, right? Typically, for fast moving averages, we use 12 as the parameter. For slow moving averages, you use 26 as a parameter, okay? So you can have different numbers here, but typically 12 and 26 are used as the parameters for fast and slow moving averages. And once again, I just want to build an intuitive understanding of what we are trying to do here, right? So again, just think about moving averages, right? If you have calculated moving average of a stock, right? So say Amazon, which we discussed in the previous lecture video. And what happens if your stock price chart, the closing price chart, line chart that we talked about, right, that we saw, what if it cuts the moving average line from below, right? So just visualize a moving average line and then the stock price, closing price line chart, cutting it from below, right? So it would signify that the stock is on a bullish phase, right? Because it has been able to breach its, moving average, right? That means, so again, it's on a very basic level. That's what it signifies. That's what moving averages signify, okay? So what we do in this case is first we calculate these two moving averages, let's say 12-day and 26 days, right? Then the difference between these two moving averages is called MACD, right? So you will have two series of data, one 12-day moving average and one 26-day moving average. All you have to do is find a difference between the fast and the slow moving average, right? So you will have a series of differences and that series is called MACD. You can also plot it on the chart and that would be your MACD line, right? But that's not all. Once you calculate the MACD line, we then perform another moving average and that's the moving average on the MACD line, right? And that is called a signal line, right? Again, moving averages, think of moving average as one series, right? You can also put that on a line chart or something like that, right? And then what you have to do is then again find the moving average of this particular line. Typically, we use a parameter 9. If you're using 12 and 26, you may want to use 9. That's what typically is used, okay? Again, you can have different numbers, but these are the most popular numbers, okay? So first we have an MACD line, which is a difference of fast moving and slow moving averages. And then you have the moving average of MACD line called the signal line, okay? So you have two lines. So how do we interpret these two lines? And I'll show you in a bit. I'll show you on the actual kind of chart how we can perceive this and how we can interpret this, right? So when the MACD line, which is the difference between the two moving averages, right? If it cuts the signal line from below, then it signifies bullish period. And if the MACD line cuts it from above, then it signifies a bearish period, okay? So if it cuts from below, bullish, cuts from top, it is bearish. And I'll show you on the chart, it will become more clear, right? But just try to understand, right? This is called crossover strategy. So if you are simply using this kind of, if you're simply looking at these lines cutting and then you're placing trades based on that, this is called crossover strategy. But there is a bad news for you if you're simply going to use only MACD. This is kind of infamous for giving a lot of false positive, okay? Especially if market is not trending, MACD is known to give a lot of false positives, okay? So it is always suggested that you use this indicator in conjunction with another indicator, okay? Just keep that in mind. Don't use MACD standalone. It will give you a lot of false indicators, okay? And again, this is a lagging indicator. This is MACD simply confirms a trend. It is not a predictive indicator which you can use to kind of predict which way the market is going to move. So let us now go to the chart and see how we can apply MACD technical indicator to our charts. So let us use the same chart that we used for our moving average discussion, and let us implement MACD on this. So first of all, let me remove this moving average indicator. So delete indicator and then insert indicators, oscillators. So MACD, as we have discussed, comes within the family of oscillator technical indicators. And here, let us select MACD. So by now, you should have a good understanding of what is fast, slow, and the MACD SMAs. Typically, these values are 12, 26, and 9, but feel free to tweak them based on your strategies. And we'll be applying MACD to the close price, so I don't need to change this. Alright, so let me click on OK. And we have got the MACD panel right below the price chart. And the MT5 platform has a bit strange representation of MACD. I mean, if you look into any other chart, MACD is presented in a different way. So typically you will get an MACD line. Here what they have done is that they have presented bars. So these bars are actual MACD values. So I want you to visualize an imaginary line joining the tip of each of these white bars. So this would give you the MACD line. And this red dotted line is the signal line, which is the EMA on this imaginary MACD line. Now let us look at a bullish crossover. A bullish crossover is when the MACD cuts the signal line. Here it's the other way around. So here the MACD is cutting the signal line from top. So this would give us a bearish indicator. And actually this was a pretty nice signal. So we got a bearish indicator here. And you can see that the price actually went down following this signal. So this was a good signal. Let us look for a bullish cross. Let us go back in time. Let me disable the auto scroll chart. Yeah, this one looks like a bullish crossover. So this is the MACD line and it cuts the signal line from below and then it went above it. So this happened somewhere here. So this was also a decent line. In the short term, it went down, but then it went up. So this was also a decent bullish signal. So you can go back in time and, verify visually whether this indicator picks your interest or not. Again, it's a pretty decent indicator, but as discussed, it gives a lot of false signals as well. So you'll have to be a bit careful when using this. Right, now let us go to the documentation and see how TradingView actually implements MACD. Alright, so I'm going to search for MACD moving average convergence divergence under scripts. Click on it. Go to read more. And in this article, you will find everything that you need to know about MACD. But what I'm interested in is the calculation, which is mentioned here. Again, fairly straightforward. We have already discussed EMA. So the MACD line is nothing but a simple difference between the fast-moving EMA and the slow-moving EMA. Again, in this case, they have used the values of 12, 26, and 9, which is the most widely used fast-moving, slow-moving, and the MACD average that people use. But you can change this with whatever value you want to use for your technical indicator. So MACD line is the difference between two EMAs, and signal line is simply the EMA of the MACD line. And then histogram, if you want to calculate, is simply the difference between MACD and signal. Not a lot of people use histogram, but we are going to implement it because TradingView has provided it. And in case you want to use it, just for the sake of completeness, let us have histogram as well in our code because it's simply the difference between the MACD and the signal line. Alright, so I'll stop this lecture video now. In the next lecture video, we will be implementing MACD using this calculation. Thank you. Hello friends. Implementing MACD should be fairly straightforward, and that's because we have already implemented EMA function a few lecture videos back, and if you recall, MACD is nothing but a set of EMA functions implemented on different values of our time series. Let us create this function called MACD, and in the argument, instead of passing a specific column or a series, this time let me pass a data frame. And I'm passing a data frame because MACD function returns more than one row of values. It returns both MACD and signal. And if we pass a data frame, what I intend to do is that I want to append these two columns to the same data frame and return that to the user. That way it would be more convenient. You can work with series just to be consistent with what we were doing earlier. But you will see that when I'm implementing MACD in the strategies, I like to pass a data frame and get the same data frame back with the MACD columns added to that same data frame. So I'm going to pass a data frame as an argument. Then we will have to pass the 3 time periods that we saw are required for user to input. And by default, these are A is equal to 12, B is equal to 26, and C is equal to 9. The fast moving period, slow moving period, and then the period over which we will calculate the average of the MACD line for signal. Alright, and now let us implement it. Let me copy these 3 lines so that I don't have to keep doing back and forth. Let me paste it somewhere down here. First of all, let me create a copy of the data frame that we are sending. Actually, let me change the format. Let me make this capital and this small. I usually work with small letters. Within the function, the local variable, let me have the small letters. And this would be big letters, df.copy. Alright, so first of all, let me add a column called moving average fast. And that would be the exponential moving average of the close price using this argument, A is equal to 12, the fast moving average. So EMA, the series that we need to pass, and this series is going to be df.close, or you can use this notation, df name of the column, df close, the same thing. And then the argument over which we want to calculate the average, that would be A. Likewise, let me copy this line, paste it here, and instead of fast, let me make this slow, and this would be B. And MACD would be the difference between the fast and the slow. So df MACD is equal to df MA fast minus df MA slow. So we have taken care of this first expression. Now the signal line is the 9-day EMA of this MACD that we have calculated. So df signal is equal to EMA df MACD, and this time we are calculating the EMA over C periods. So signal is calculated, and if you want to calculate histogram, although we are not going to use this, but a lot of people like using histograms as well. So DF histogram is simply the difference between the MACD and the signal line. So DF MACD minus DF signal. And then we are going to return data frame. We are going to return these three columns, MACD, signal, and histogram. So if you are returning multiple columns, you need to put the names of the columns within a list. That's how it works in pandas. So it would be MACD, signal, and histogram. And that's pretty much it. So let us test it. Let me remove this. So his data, let me copy these three column names. So instead of EMA, we'll be adding these three columns to historical data. And then we'll be passing the entire historical data frame to the MACD function. And this should add these three columns to our historical data. So let me refresh the historical data so that we don't have the EMA column from the previous lecture videos. Okay, so we have got a refresh of the historical data. And now let me run these three functions and the final line of code. Let us check out our historical data. We have got MACD, signal, and histogram. Let us check out the MACD values. Let us double check on the chart. Alright, so the MACD value here is minus 0.000352 at 6 p.m. But you can see how this value is changing because the market presently is open. So we should not really match the unfinished candle. You see the value changed to minus 0.00345. So let us compare the finished candle. So 5 p.m. the MACD value was minus 0.000449. Let's double check. So 5 p.m. minus 0.000449. You can see that there is some rounding going on here. And what about the signal line? Minus 0.000616. So this is the signal line minus 0.000642. And then the previous MACD value minus 0.000573 minus 0.000573. So you can double check. You should be matching these values fairly closely. Alright, so just go through the code. It's a fairly straightforward implementation. Let me know if you have any questions. Thank you. Hello friends. So in this video, we'll discuss the basics of RSI or Relative Strength Index. So RSI is again a very popular technical indicator, and it is known as a momentum oscillator, which measures the speed and change of price movements. So what RSI essentially conveys is what's the strength of the price value of a stock at a given moment compared to its previous stock prices. And you will see how it is arrived, and that will give you a better understanding of what RSI is trying to do. And its value oscillates between 0 to 100. And if the value goes above 70, then it indicates that the asset has now it is now overbought and a correction is expected, right? And then if the value is below 30, then it signifies that the asset is oversold and that a pullback is expected. Or if it's less than 30, then people expect the price to go up. The 70-30 is typically observed in developed markets. In a lot of emerging equity markets, it's usually 80-20. Problem with RSI is that even if a stock has an RSI of 80, and you may think that, hey, I should short it because it is expected to go down any moment now. But you will see that a lot of times the overbought position can persist over a very long period. So the RSI can hover from 70 to 90 for like even as long as over a month, right? So that's the problem that RSI has, is that it's not that as soon as it touches that particular mark, it is certain that a reversal is likely. But more often than not, it does happen. So let me show you how you can insert RSI technical indicator on your chart and how can we interpret it. So first of all, let me remove the MACD indicator. I'm clicking at the wrong spot. So here, delete indicator window, insert indicators. And as we have discussed, RSI is also an oscillator. So here, let us click on relative strength index. So again, you have to choose over what period we have to do the averaging, etc. And let us go with the default value, which is 5. Then within levels, you can mention what's the overbought and oversold limit that you want to go with. Do you want to go with 30/70, 20/80 or whatever? And you can change this by double clicking on this value and updating it. Alright, right now I don't want to do anything, so I'll just click on OK. And you can see that I've got the 5-period RSI here with the overbought line being at 70 and the oversold line being at 30. And you can see that USD CAD had recently ventured into the overbought territory, and now there has been some pullback as expected. Let us go back in time and see if there were some other good signals or not. So this one here, so this is when it entered the oversold territory. So somewhere here, but then as you can see, it continued in the oversold territory for quite some time, and then the bearish phase started. Although there was a pullback, you can see that had you entered here and initiated a short position, you probably would have stop lost. So timing your trade entry is very critical when you're working with RSI. Just entering the oversold territory doesn't mean anything. You need to figure out when the pullback has actually started. Okay, so that's very important. Let us look for any buy signals, meaning oversold territory. Yeah, this could be considered a decent signal. So here, USD CAD entered the oversold territory. And a lot of traders may have been tempted to enter long position, and they would not have been disappointed because this was a decent signal, but there was a bit of a bump here. So again, you will have to be a bit careful with how you interpret and how you. So again, a fairly easy technical indicator to interpret and work with. Let us now go to the TradingView documentation and see what is the calculation and how we can implement RSI. Right? So let us search for RSI and then let us go to the documentation. Again, a very descriptive documentation, but we are interested in the calculation part, so I'm going to limit the discussion to this section. So here, TradingView has explained using something called Pine script. So Pine script is TradingView's native programming script, and all the functions that they have implemented is using Pine script. But it's fairly easy to understand what they are doing. You don't have to know Pine script, so let us see what the below Pine script is telling us. So first step is pretty obvious. We need to calculate per period change in the closing price. So this change function simply calculates the difference between one period compared to the previous period. Then they are calculating gain and loss, which is identical to what we did in Excel. If this change that we calculated in the previous step is a positive number, then gain is equal to that change. Otherwise, it's 0. For loss, if this change is a negative number, then loss is equal to -1 times the negative change that we have. So this gain and loss will always be positive numbers. So if you have got the change value, which is negative, we simply multiply it with -1. If the change is not less than 0, then we assign a default value of 0. Then this is a tricky part, average gain and average loss. TradingView has used a function called RMA, and I'll get to that in a bit. But for both average gain and average loss, we simply apply gain and loss respectively to this RMA function, and that's how TradingView is calculating average gain and average loss. So once we have calculated average gain and average loss, then it's fairly straightforward. We calculate the relative strength by taking the ratio of average gain and average loss, and then RSI is equal to 100 minus 100 divided by 1 plus relative strength. Alright, so pretty much all the steps are identical to what we have done in Excel, except this average gain and average loss. So I was not able to find any documentation on RMA, but I was able to find an article in TradingView in which they have explained what is RMA. So here they are saying that RMA is moving average used in RSI. So RMA is again a moving average, but we need to know what is the implementation of this moving average. And that is what they have mentioned there. It is the exponentially weighted moving average with alpha is equal to 1 divided by length. If you recall our previous discussions where we have implemented exponential moving average, we have used something called a multiplier, and that multiplier was 2 divided by n plus 1, where n is the number of period. In this case, they don't have anything called a multiplier. They're simply using an alpha, and this alpha is 1 divided by period or length. Alright friends, so let us now implement RSI using the calculation logic that we saw on the TradingView documentation page. Again, it should not be that difficult. The only thing that we found a bit tricky was the use of RMA, which is a special kind of moving average. So my starting code is the moving average code that we put together a few lecture videos back in this section. All that I'm going to do is change the name of this function to RMA. And the only thing that we'll change is how we define the multiplier. The multiplier in this case would be 1 by n. I think they call it alpha. That's fine. We can keep calling it multiplier. And this would essentially give me the RMA. So essentially what we are doing is that we are changing the weight assigning logic for this particular exponential moving average. So it's not that much of a difference. Now let us create the RSI function. Let me define the function called RSI. Once again, I'm going to pass the data frame and the argument n, which is the period over which the average needs to be calculated. By default, let me give the same default value that MetaTrader uses, which is 5. Alright, once again, let me create a copy of the data frame so that we don't inadvertently make any changes to our original data frame. And this data frame would be the open, high, low, close data frame. Actually, let me again pass some value to this data frame so that I can show you what's going on step by step. It is very important to understand what's going on in this case to get a better understanding. So we've got the historical data, and we will be passing historical data to this function. So let me pass historical data to df, and then let me store 5 as a value to n. Alright, now let us create a copy of df, which is small df. Great. So now we have got the USD CAD open, high, low, close data frame. Now if you recall, the first thing that we need to do is calculate the per period change. So let me create a column called change, which would simply be the difference of the close price compared to the previous close price. And how do we find the previous value in a data frame? Using the shift operator, dot shift 1. So this will essentially take the difference between the successive close prices. So the first value would be 1.35253 minus 1.3518, and the second value would be 1.35163 minus 1.35253, and so on and so forth. Okay, now if you remember, the RSI function defines gains and losses as the absolute value of the gain or 0 if there is no gain. So we can very easily implement this condition using numpy's where function. So numpy.where, again, numpy.where is very similar to Excel's if function. So first we give the condition, then what is the value if the condition is met, and then what is the value if the condition is not met. So if df change is greater than 0, then it would be df change, else it would be 0. Let me copy this thing, and just like gain, we will have to create a column called loss. So if this is less than or equal to 0, then it would be minus 1 into df change, or you can use absolute of the df change. I'll leave that to you, else 0. So now if you recall, we will have to calculate the average gain and the average loss using the RMA function. So average gain is equal to RMA, the gain column, and likewise, we'll have to calculate the average loss. So average loss would be RMA on the loss column. Right, so now the bulk of the heavy lifting is done. Now all that we have to find is the relative strength and the relative strength indicator. So relative strength, if you recall from the formula, is simply the average gain divided by the average loss. So average gain divided by average loss. And then finally, RSI is equal to 100 minus 100 divided by 1 plus relative strength. So 1 plus DFRS. That's pretty much it. And we will return DFRSI. Let me quickly run a few lines of code to give you a better understanding. So if I open DF, we have got the change column, and then we have gain and loss. And you can see if we have got a positive change, that's the gain value. If we have got a negative change, the absolute of that is the loss value. Alright? Now average gain and average loss is simply the RMA of these series. So if I run these two lines of code, sorry, I have not run RMA again. I keep doing this. Alright, so now if I run this, we've got the average gain and average loss, and this is the RMA of gain and loss, a specific type of exponential moving average, but we understand the math behind it. And once you have average gain and average loss, it's fairly straightforward to calculate RS and RSI using the defined formulas. So if I run this, RSI oscillates between 0 to 100. So let's make sure that the number makes sense. So yeah, looks like we have got the correct values of RSI. It is oscillating between 0 to 100%. Alright, so let us test this now. So hash data RSI is equal to RSI hash data, and we should be done. So let me refresh the historical data and let's double check the values that we get to make sure we are not doing anything wrong. Alright, so if we go to historical data for USD CAD hourly data, you've got the RSI as this. Let us verify these values from the chart. Alright, so USD CAD hourly data, RSI at 7 p.m. is 49.88. Again, this is not a completed candle, so I will ignore it. Let's go to this one. At 6 p.m. it's 44.12. 6 p.m. 44.12. 5 p.m. is 74.80. 5 p.m. is 74.80. And you can double check. Your calculated value should be fairly close to what we have on the MetaTrader platform. I have double checked it. Alright, so go through this code. We are going to use RSI in one of the strategies. So it's very important that you have a good understanding of this technical indicator. Thanks a lot. Hello friends. We'll now talk about stochastic oscillator. Stochastic oscillator falls within the momentum-based indicator family, and it measures the speed or momentum of price change. This is very important. So make sure that you understand this, that what stochastic oscillator is trying to do is that it tries to measure the momentum or speed of price change. Okay? This is based on the premise, like this entire calculation of stochastic oscillator is based on the premise that calculating momentum is important because before price action happens, before price reversal happens, momentum must change. For example, if there is an uptrend and the price is going up and up and up, then the momentum or the rate of change of the price, right, that has to first reduce and then reverse before the price action can reverse, before the stock can start coming down. The momentum has to stop, and then it will come down. Okay, so that is the whole premise. I mean, I say it's a pretty reasonable premise if you are in a trending market. Okay, in sideways market, it works horribly. But if you have been able to establish that there is an underlying trend, then you can use stochastic oscillator. It can work. Okay. The calculation is fairly straightforward, right? All you have to do is take the present close price, right? Then you have to subtract it with, lowest low over a given time period or a given look back period. And then you have to divide it by the highest high over the same look back period and lowest low over the same look back period. So you take the difference between highest high and lowest low. You take the difference between close and lowest low. You divide them, and that gives you the stochastic oscillator value, also called %K. Okay. So that's fairly straightforward. Lowest low and highest high, I mean, we will look into the Python implementation, but you can already figure out that you will have to use a rolling method, right? For lowest low, you will have to use a rolling function and then use rolling min. For highest high, you will have to use a rolling function and then use rolling high. Okay, so that's very straightforward. I mean, I think you can already figure out that it will take not more than 2 or 3 lines of Python code to implement this. Okay. So the value of stochastic oscillator ranges between 0 to 100, okay? But a value closer to 100 would signify that the present price is closest to the highest price that the stock had over a given time period, okay? And the value closer to 0 would signify that the price right now is closer to the lowest low, right? Or the valley that the stock price experienced over the look back period. Okay, that's not that difficult to interpret. Again, just like RSI, 80 would indicate that there is an overbought territory and 20 would indicate that it's an oversold territory. However, don't just blindly place trades looking at 80 and 20, because once again, these numbers are only telling you the momentum. A number less than 20 tells you that the momentum is really low now. Okay, and a value more than 80 is telling you that the momentum is really high right now. So that speed is pretty good. The rate of change of price is pretty good. Okay, so that's what it is saying. It is suggested that you use it along with other indicators. Needless to say, I mean, you can figure out that using this standalone could be very dangerous, right? So just something to keep in mind. There's one more thing is that in some stochastic oscillator implementation, you will see two lines, right? So you will have this %K line, which is called stochastic. And then you will also see that there is a moving average of this particular line that you will calculate. And then you will have two lines, right? So, I mean, when I will write the code for this stochastic oscillator, I will also create both those lines, but you wouldn't really need it. Typically, you would need just one. Just this line, right? Close minus lowest low by highest high minus lowest low. Okay. So let's get to the chart and let's see how you can interpret stochastic oscillator. All right. So continuing on our USD CAD chart, let me first remove the RSI panel and let me insert from within the indicator again. We'll have to go to oscillators and then choose stochastic oscillator. Again, I'm going to leave the default arguments as it is. You can see that %K is 14%, D is 3. And then in the levels, by default, it is 20 and 80. So I'm not going to tinker with the default. But if you want, you can do that. So let me click on OK. And you can see that we have got both the %K and the %D lines. The green line is the %K, and then the moving average on the %K, which is %D, is the dotted red line. Again, you just need one. Some people like to use the %D line. Some people used to like the %K line. I leave that to you, which one you want to use in your strategies. Again, if we go back in time, we can see that there is a tendency to remain in the oversold or the overbought territory for a longer period of time. So, for example, in this case again, you see that we got a signal here of being oversold. But you can see that this oversold remained for quite some time. It remained till this point, till here. So you could have booked a significant loss if you entered a short position here, but there was definitely a pullback. So there was a bearish phase after that. But the problem is that there is this tendency, just like RSI, to spend a longer duration in overbought or oversold territory. But that's not always the case. Sometimes it's pretty quick. So for example here, yeah, this could be considered a good signal. A good short-term gain could have been booked there. And you can go back in time and you can double check. Now let us check out the implementation of stochastic technical indicator in the TradingView documentation. Alright, so let us search for stochastic. And as soon as you type in stochastic, you will see a bunch of options of technical indicators. There are a number of technical indicators that uses some form of stochastic, but choose the one that says stochastic oscillator. That's the one that you want. Okay, let us click on read more. And this is the exhaustive documentation of the stochastic technical indicator. But I'm interested only in the calculation bit. And you can see that the implementation is exactly the same to what we discussed earlier. The %K line is the simple moving average of the current close minus lowest low divided by highest high minus lowest low. So stochastic can be broken down into two lines, %K and %D. So %K is the percentage of price at closing within the price range of the number of bars used in the look back period. So this look back period is the option K, that you saw when we were implementing this technical indicator. So the highest high and the lowest low would be calculated using this look back period. So once we have got the lowest lows and the highest high, calculating this is fairly straightforward. All that we have to do is use the SMA. So this is %K, and once you have %K, you can calculate %D as a simple moving average of the %K line. You typically need just one of these two. If any one of these lines breach the 80-20 limit, we state that the asset is in overbought or oversold territory. But when we are going to implement this function, we will implement both these lines because it's very straightforward. Alright, so let us now implement stochastic. Hello friends, so let us get down to implementing the stochastic technical indicator. So let me define the function stochastic. We are going to pass the data frame, the look back period to calculate the highest highs and the lowest lows. Let me use 14 period by default. Then we want to use period over which we'll calculate the SMA for the %K line. Let me use K is equal to 3. And likewise for %D line, which would be the SMA over the %K line, I'm again using D is equal to 3 or 3 period. Let us copy the original data frame to not change any values in that. Let us create the highest high column. Can you make a guess? How will we calculate the highest high? So we will access the high column. Actually, let me use the column name because some people get confused when I use the dot operator. So high column will be using the rolling operator. We will use the rolling max. So look back dot max. Again, if you don't believe me, let me pass the historical data. Let me run historical data again. Let me pass historical data to data frame. Alright, df copy. Let me pass 14 to look back. Now if I run this line of code, you will see that the highest high, this value, is the highest among these 14 values. 1.35416 would be the maximum value in all these 14 values. Then the next value again would be the maximum value between the second value and the 15th value. So on and so forth. So once again, rolling is a very useful operator that Pandas provides. Make full use of it. Likewise, we'll also make the lowest low. So LL is equal to df low dot rolling look back, and this time we'll have to use the min function. Sorry, I missed the parenthesis here. Now calculating %K is very straightforward. So df %K. Again, you can use a different symbol. If you don't like this %K, I'll leave that to you. So again, let me go back to a documentation because I don't recall the formula. So let me copy this. So this is SMA of current close minus lowest low. So df close minus df lowest low divided by highest high minus lowest low. And then we have to apply a simple moving average to this expression. So we can either pass this to the SMA function or just let's do a rolling mean. So rolling, let me actually wrap the whole thing in another bracket. So here we'll be passing the argument as K dot mean. Alright, so that's taken care of. And then finally, the %D line is simply the rolling mean of %K. So df %K dot rolling D dot mean. And we are going to return both %D and %K. %D, %K. And that's pretty much it. Let us now quickly double check our values, whether we are getting the right values or not. So historical data, let me copy this, %D, %K is equal to stochastic historical data. Let me run these lines of code again. Oops, I think I missed multiplying this by 100. And also let me not flip this. So %K, %D, %K, %D. Right? So if I open historical data, we've got %K and %D. Let us double check for USD CAD. Okay, so once again, let us look at the second last finished candle. So we have got %K as 54.66. But here we got 54.8421. What's the previous one? So for 5 p.m. we've got 56.48. And for 5 p.m. we've got 55.6481. So not that close to my liking, but still reasonably close. If you want to get the exact value, I suggest look at the actual implementation in the MT5 RSI documentation and see how it differs from TradingView implementation. Most likely they have used exponential moving average and not SMA, but I leave that for you to investigate. So let me know if you have any questions pertaining to stochastic. Thanks a lot. Hello friends. We will now discuss a trading concept which is not a technical indicator per se, but it is used widely by technical analysts, and that is called support and resistance. Now, what is support and resistance? So support and resistance are two imaginary levels on a price chart, which gives traders an idea about the price points at which the asset price is facing difficulty to breach. So for example, this is the USD CAD hourly chart, which we have been seeing for a long time now. So for example, if a technical trader is looking at this chart, he or she will probably go back in time and try to figure out price points where the price bounced around a bit. So what it means by bouncing around a bit is that the momentum is carrying the price, but as soon as it reaches that particular price point, there is some resistance to further breach that barrier. So for example, in this case, if I am analyzing this, I would consider this point to be a point of resistance. Likewise, if I go back in time, if I was somewhere here, if I was trading somewhere here, then I would consider this price point around this neighborhood to be a point of resistance, because you can see that the price tried to breach this particular level a number of times, but every time it reached here, it went down. And when it actually breached that particular resistance, you can see that there was significant momentum on the upside. So these are a few examples of resistance. Now let us check for support. So support is similar to resistance, but it is on the lower end of the chart. So resistance is an imaginary line which tells traders that it's difficult for the asset to go below this particular level. Alright, so let me analyze this. Yeah, so here, this is an easy resistance. So these 2 points, somewhere in this neighborhood, I would consider was a resistance which has been breached recently. And you can see that as soon as the breach occurred, there was a reasonable momentum on the downside. Alright, so support and resistance are very important trading concepts that technical traders extensively use, and it's very important that we try to implement them in our strategies. This is the first time I am discussing support and resistance in any of my courses, so I would very much appreciate if you have any feedback about the approach that we are going to take. And once again, there are a number of approaches that quantitative traders use to determine the support and resistance. No specific approach is superior or inferior. It all depends on what is your trading style. I am going to implement one of the approaches which I feel reasonable, but let me qualify, that's not the only approach to determine support and resistance. There are a number of other approaches as well. So you are free to change the approach that we are going to discuss. Alright, so how am I going to determine the support and resistance through a Python code? So the first thing that you may have noticed when I was trying to determine support and resistance, I looked at these hills and valleys. I told you that this particular point is there were 2 hills that had almost the same height. Likewise, if you see here, there are 2 valleys which have almost the same depth. So the first thing that we'll have to do is determine all the hills and valleys in this particular chart. And again, I leave that to you how you want to define your hills and valleys. So for example, in this case, this is a clear hill, but would you consider this a hill? It's more like a plateau, right? Because the tip is kind of flat. But some people may consider this as a hill as well, and they may consider this for their support and resistance calculation as well. But what I'm going to use is I'm going to use a clean valley and a clean hill, which means a pointy tip and a pointy bottom. Alright, so with this understanding, let us first implement our hills and valleys function, and then later we will use the hills and valleys to determine our support and resistance. So let us get back to our code. Alright, so we'll start with the historical data. Let me run the whole thing again. Alright, and we've got a historical data. Now I have to go back in time and figure out where there were hills and where there were valleys. Alright, so let me first create a function, get hills and valleys, and we are going to pass the data frame. Actually, let me again make this capital letters because we are going to create a copy. Alright, and the first thing that we need to do is create a copy of the data frame that we have passed, just like in the previous technical indicators. So let's continue to do that. Now, what we need to do is create another column called hills and valleys. The idea is that we are going to have a column called hills and valleys. And then if a particular point is a hill, we will identify that as a hill. And if a particular point is a valley, we will identify that as a valley. And I'm using this representation because we want to test it. And if we have a literal representation of hills and valleys, we can very easily go back to the chart and visually see whether our implementation makes sense or not. Let me make this singular and not plural because every specific point is either a hill or a valley. Alright, so let's do that. Now, how do you propose we get the hills and valleys? It should not be that difficult. All that you have to do is compare the low point of a given candle with respect to the subsequent few candles and the previous few candles. Alright? Actually, let me convert this into a candle. So you see this low point here? I call this as a valley because this low point is lower than this low point and also this low point. Likewise, this low is also lower than this candle's low and this candle's low. So if we keep analyzing a set of 5 candles and we traverse through the entire historical data, we should be able to identify the hills and valleys. Again, it's an hypothesis. Let's implement it and see whether we get reasonable results or not. But just one thing I would want to add here is that sometimes if you just compare this low with this low and these lows are almost the same, then you would again have something like a plateau. And that's okay. You can have a valley with a slight plateau, but I want to have a steep hill and a steep valley with very pointy tips. So what I'm going to do is I'm going to add another condition is that the difference between the valley and the adjoining points should be greater than a specific number. 1 pip, 2 pip, 3 pip, whatever. Alright, so that's one thing I'm going to add in my implementation. So I am going to need pip here as well. Let me pass the default value of 0.0001, which is the pip for most currency pairs, except currency pairs having APY. But when we are running this function, we'll have to pass the pip for a given symbol. And I'm going to use numpy's where function, which is very similar to Excel's if function to implement this. So all I'll do is pass the condition that a given low is lower than the adjacent candles on both the sides. If that's true, I'm going to mark it as a valley. If that's not true, I'm going to mark it as a blank. Now, implementing this condition is going to be tricky because there is not just one condition. We have to compare the lowest low with the previous candle, then with the previous to previous candle. Likewise, we have to compare the lowest low with the next candle, next to next candle. So there are actually multiple conditions and they could all be combined using an AND operator. So what I'm going to do is that I'm going to use the numpy's logical AND function, which performs exactly the same function as your AND operator if you have studied set theory. So here, I have to compare the low price of a specific candle with the previous candle. So df.low shift 1. By now, I expect all of you to be comfortable with basic pandas functions like shift. And just to make the tip a bit pointy, I'm going to use a 3 pip difference between the low and the previous low. Alright, so this is the first condition. Let me wrap this entire condition in a bracket. And then within this AND function, we'll be passing another condition, which is very similar to this. But instead of comparing it with the previous candle, we'll compare it with the previous to previous candle. Alright, okay, and these brackets are becoming a bit overwhelming for me. So let me format this code so that you can analyze it easily. So this bracket would go here because it corresponds to the AND. Alright, but this AND function is not done. We need to have the same thing for the next two candles as well. So let me copy this whole thing and let me paste it here. Let me fix the formatting. And here instead of 1, we'll have -1 and -2. Alright, so if this condition is true and this condition is true, so we'll have to wrap this whole thing in another NumPy logical AND. So this is going to get a bit hairy, but bear with me. So another logical AND. So it's a nested AND condition that we have used. And then let me wrap this whole thing within this. And let me fix the formatting. Alright, so if this entire AND condition is true, we are going to make this hill valley column, the value for that particular row, as valley. Okay, I think I messed up the format here. There should be .shift1. That's why I was getting confused with the parentheses. There are more parentheses than I would expect. Just give me 1 second. Let me fix this shift. Alright, so this logical AND function starts from here and ends here. Now this is one of the arguments for this logical AND function, and the second argument is this. So this entire thing comes within this logical AND function. So this is taken care of. So this parenthesis is taken care of. So NP, where this entire thing is the condition. If it's true, then it's valley. If it's not true, then let me give it as blank as for now. And let me close this bracket. And let's see whether we get an error or not. So let me store the value of 0.001 in the pip variable. Let me copy historical data into df. And let me store the copy of historical data in small df variable. Let me run this now and see whether I get what I want or not. Okay, looks like it ran. If I open df, alright, so we have got valley, that's great. I still have to implement hill. I just want to make sure that the valley implementation is correct. So the first valley I'm getting is for 29th Jan, 2 p.m. Let's double check it. So 29th Jan, 2 p.m. So this is 29th Jan, 2 p.m. Let us double check that it's the same candle in the data frame. So the close price is 1.34364. Close price is 1.34364. So we are looking at the same candle. This does look like a valley. Okay, so you can see that there is a valley here. Let me make it a line chart to make it look clearer to you. Okay, and this as expected has not been identified as a valley because you can see that this is a plateau. I would expect this point to also be a valley. Let's make sure that this is identified. So what's this point again? So it is 26 Jan, 3 p.m. So if we go to 26 Jan, 3 p.m., yes, great. So looks like this valley is working as expected, but once again, this is not the full implementation. We also need to implement the logic for hill. So it would be similar, but the only problem is going to be the format because it's going to get messy. So instead of blank, we are going to have another numpy where. So numpy dot where, and then within this, I'm going to copy this entire thing. The formatting is going to be a nightmare, but I'll try my best. And I'm going to paste it within this. And then here, all the lows would be highs. So df.high, high. And then I'll have to flip the inequality sign and make this plus 3 pip. Okay, likewise, let me change that for all the conditions. I'm forwarding the video. Alright, so I've taken care of that. So instead of valley, this would be hill. And if even this condition is not satisfied, then we'll be assigning a blank value. Alright, so this is the implementation. The only thing I'll have to do is fix the formatting. So let me forward the video while I fix the formatting. Alright, let me quickly run this and see whether we get the hills or not. Alright, so yeah, looks like we've got hills and valleys as well. Let us double check whether we are getting correct hills or not. So we've got a hill for 29th Jan, midnight. So this 29th Jan midnight is identified as a hill. Yeah, looks correct. I would expect this also to be a hill. This is 26 Jan 7 p.m. Let's check it. 26 Jan 7 p.m. Okay, so looks like it missed out. maybe we are not fulfilling the 3 pip requirement, which is unfortunate. So you may want to consider reducing that 3 pip difference to something more palatable, because you can see that we missed a few small peaks. Then what's the next hill? 26 Jan, 9 a.m. Which one is that? It looks like it would be this. Let's double check. Yeah, 26 Jan, 9 a.m. This is a clear hill, so we have been able to identify it. So you can see that this code is working when we have a very clear pointed hill, but we are missing out things like this, which could be considered hill by a technical analyst. Alright, so this is the code. Play with it. The whole point is to give you an intuitive understanding of how we can start implementing resistance. So this is the first step towards identifying support and resistance. In the next lecture video, we'll build on this code and we'll try to get support and resistance using hills and valleys. So I'll see you in the next lecture video. Thanks. Hello friends. So continuing from where we left off, we now have the hills and valleys given a historical data frame. Now all that we'll have to do is use the list of these hills and valleys to determine our support and resistance. So we are going to discuss getting support in this lecture video, because that is going to take some time. I don't think I'll be able to cover both getting support and getting resistance, but I'll share the code. But I encourage you to gain a thorough understanding of how we are going to implement finding the support point and then using that implement getting resistance function as well. Although I'll provide the solution, but it will be great if you give it a try. In this function, we are obviously going to pass the list of all the valleys. So again, support is the lower point in the chart, and the resistance is the upper point in the chart. So valleys are relevant for support. So from this function, we'll be getting all the valleys and then we'll be passing this valley. So let me call this list of lows to this function. And one very important thing is that you would definitely need the current price to determine the support price, because your support price has to be below the current price. If your support price is above the current price, that doesn't make any sense. So you always want to find the support and resistance being cognizant of the current price. So that is very important. So we'll have to pass the current price. What else do we need to pass? Again, if you recall, I told you when we were discussing the chart is that the rebounds may occur within a range. So the resistance may not be an exact point. So let me again explain to you through the chart. So in this chart, if I tell you that this is the support level, this point, let's say here, so you see that, these lows or these valleys are not exactly on this line, but they are in the neighborhood. So you may want to determine a neighborhood or a band in which if you found multiple valleys, you count them as relevant. So let me call this argument as level range. And let me give the default value of 20. Again, you may want to change it. You may want to change it to 10 pip or 5 pip. So, and then we'll also need the pip. So let me give a default value of 0.0001. But we'll need to pass the pip value based on what symbol we are working with. Alright, so let us start implementing the get support function. Let me give you a heads up. It is going to be a bit involved. So pay close attention. So we will be calculating all the support values that we have identified and we'll be storing them in a list. For example, if I have historical data going back 1 year, this is my current price. So I may find this as the support level. Then I may also find this as a support level. Well, but this point is above the current price, so I'll discard it most likely. So any significant support level that I find which is below the current price, I will store all of them into a list. Alright, so that's how I'm going to store all these supports. Now let us iterate through the list of lows. So for index and the actual value of the low in enumerate list of lows. I hope all of you know what enumerate function does in Python. If you don't, look it up. Essentially, when we are iterating, it gives us both the index of each dynamic variable and also the actual variable. Okay, so let me tell you what is the algorithm I'm going to use. So let's say I have got these values as my low: 20, 22, 18, 28, 17, 23, 25. Alright, so let's say these are the imaginary low values. What I'll do is that I'll start iterating from the first value And then I'll check which of the subsequent values are in the same ballpark as 20. And if I find at least 2 or 3 or 4 occurrences where the number is close enough to 20, I will add 20 to the support level. Alright? Then I'll go to the next value. Again, I will iterate through all the values that are after 22. So we'll have to have some kind of a nested loop. So one loop will go from the first value all the way to the last value. But for every single value, we'll also have to check all the subsequent values. So there'll be 2 loops that will be required. And if we find a minimum number of occurrences, wherein we find a value close enough to 18 or 28 or whatever number you are analyzing, we will add 18 to the support level. Alright, and a few things that we'll have to do if we want to implement this is that as soon as we find a given support level, we should remove it from our further analysis. Alright, so let me add another variable and call it remove index. So this will store all the indices that have already been used to identify a valid support. And again, this will be the index and not the actual value. So if I figure out that 20 has already been used, I'll store 0 in remove index. And that's the reason I'm using enumerate function here, because I would be requiring the index along with the value as well. The first thing that you have to do when you start iterating is that if the index is in remove index, then we simply don't do anything. We skip the iteration. So we'll use continue command in Python, which helps us skip the iteration and go to the next iteration. Just think about it. So let's say we start our iteration. So index would be 0 and low would be 20. Is index in remove index? Obviously not, because remove index is blank right now. So we will implement the rest of the function that I have not yet implemented, but we'll do that. So the whole iteration would complete. And let's say 20 is identified as a support. Then support level would be updated with 20 and remove index should be updated with 0 and also any other values that was found to be close enough to 20. Okay, so let's say, for example, 22 was found to be close enough. So we would also include index 1 in remove index. Alright, so in the next iteration, index would be 1 and low would be 21. But in this case, index is already in remove index. So this continue will get triggered and we won't do any analysis for 22. Okay, and if this condition is not triggered, let me initiate a variable called count, because I want to keep a count of how many similar values were found. Actually, let us have another argument here and let me call it minimum occurrence. And let me give a default value of 2. You can have a higher minimum occurrence, but there is a possibility that you will not get any support or resistance. So all that I'm trying to do here is that I need at least 2 instances of values being closer to a given number. Only then we consider that as a valid support. So for example, in this case, if we had 3 and only 22 and 22 were found to be close enough and no other number were found to be in the same neighborhood, we would not consider 20 as a support level. So let us have minimum occurrence as 2. So that's why we need to keep a count. So let me have this variable and then let me have another variable called lows, where we will append all the values that were considered close enough to a given variable. Now let us implement the secondary loop. So for j in list of lows, and in the secondary loop, we will start from whatever index we are presently at in the outer loop and go all the way till the end. So index all the way till the end, and here we will implement the condition. If the absolute of the difference between the low, which is the current value that we are analyzing, minus j, which is the current value that we are analyzing in the internal loop, if this value is less than level range times pip, so level range times pip, then the condition is satisfied. We increment our count with 1 and we append our lows list with whatever value that we have found. Alright, so that will take care of the internal loop. Now once the internal loop is over, we have to check for the minimum occurrence criteria. So if count, you can also use length of lows. But since we are using count, let's use count. So if count is greater than minimum occurrence, then we have got one of the valid support levels. Support levels dot append. Now what do you want to do? Do you want to use the support level as the value that was in the outer loop? So for example, if say 20, 22 and 18, all three are considered close enough, what would you take as the support? You can take the minimum, you can take the average. I leave that to you. Let me take the average. So average would be sum of lows divided by length of lows. Okay, is that all? No, that's not all. I told you that there's another criteria, which is current price. If this support is more than the current price, then it doesn't make any sense. The support has to be lower than the current price. So we'll have to add a criteria here. Do this only if the sum lows by length lows is less than the current price. Else support levels, which means do nothing. Now at this point, you want to update your remove index with every single index associated with the values in the lows list. So let me write it down here. So remove all the indices of the values used to calculate the identified support level. So that's simple. For K in lows, remove index. Again, how will you identify what is the index in the list of lows list? So very simple. We will use the dot index function to identify the specific index. So list of lows dot index K only if this index is not already in remove index. Else do nothing. So this will take care of my support levels. Let us take care of a few other things. What if you don't get any value in your support level? What if the support level is a blank list? So if length support levels is equal to 0, again, I leave that to you what you want to do. In this implementation, I'm going to return the minimum of the list of lows. Not a very elegant way to handle this limitation, but I had to do something to not get errors, so that's what I've done here. Actually, I think I may be doing something wrong here. We again have to check whether the minimum of the list of lows is lower than the current price. So if minimum list of lows is less than the current price, only then return this. If that's not the case, simply return the current price. Now again, we want to return one support price, and here we have got a list of supports. So in this implementation, let us think of what are the various ways in which you may want to get the data. So let's say your support levels look something like this: 20, 22, 18, 9, 16, 14. So if you've got these support levels, as a trader, which one would you consider as the support? So I might consider this trough as my support level. So let us implement this particular condition. Again, you may not want to implement it this way. I am doing it this way. Feel free to change it. So if your list of lows dot index minimum of your list of lows, so what will this give us? The whole idea is that I want to see whether the lowest low, the lowest of all valleys, occurred fairly recently. All I'm trying to do is trying to identify the index of the minimum low. So this would give me the index. If this index is fairly recent, so for example, this index is 0, 1, 2, 3, 4, 5. Alright, so this index is 3. If 3 is fairly recent, so if 3 is greater than 60% or 70% of the length of this particular list of lows, so length list of lows, then we know that the major trough occurred fairly recently, and we'll simply return that as our support price. Actually, let me make this 0.7 to make it a bit more recent. Check whether a major trough occurred recently. If that's the case, we are going to return minimum of list of lows. Let me make this elif. If neither of these two conditions are satisfying, then we will take our support levels and I will return the closest frequently touched support level. So return sorted support levels, reverse is equal to true. We'll take the first value. Alright, so this is the implementation of get support. Likewise, get resistance will be very similar. I'll share the code with you when I'm uploading the code, but try to implement it yourself as well. And do test this get support and get resistance function on your end as well to make sure you have a thorough understanding. Alright, so please share your feedback about what you think about this particular implementation of getting support and resistance. Once again, there are a number of ways by which you can get support and resistance. I've just discussed one of the approaches, but happy to discuss if you feel strongly about any other approach. Thanks a lot.